Welcome back to another lesson in MCR3U. Today we'll be looking at transformations, specifically reflections and stretches with radical functions. So here, if we look at our vertical reflections, so we're comparing our original function of y is equal to f of x. And here, our transformation that's being applied is y is equal to negative f of x. And so here we see that the negative is outside of the function. And so here, if we see that we have f of x is equal to square root x, negative f of x, we can write in terms of the radical as negative square root x. So it's outside of the square root function. And here, if we're looking at our mapping notation, again, our original x and y values, when it gets transformed here with the vertical reflection, we see that the x values will stay the same, but the y values here become negative. So here, again, our original function, f of x, is equal to square root x. Then here, our transformed function, so we'll write here as f of x is equal to negative square root x. So here, again, our original table of values for original parent function starts 0, 1, 4, and 9 for the x values, and the corresponding y values will be 0, 1, 2, and 3. Here, if we look at our transformed function with the vertical reflection, our x values stay the same, and our y values are multiplied by negative 1. So here we have 0, 1, 4, and 9, same x values. Our y values then become 0, negative 1, negative 2, and negative 3. So if we graph our parent function and our transform function, here we start at 0, 0, 1 and 1, 4 and 2, and 9 and 3. So that's our original parent function. And then our transform function, negative square root x, will then be at 0, 0 starts the same spot, but 1 and negative 1, 4 and negative 2, and 9 and negative 3. So here we have y is equal to square root x, and our transform function, y is equal to negative square root. And we see what's happening here is that from the original parent function, it's being reflected across the x-axis. And so here, if we put a mirror on the x-axis, we'll see that it would be the same on both sides. So now let's look at a horizontal reflection. So if we look at our original function of y is equal to f of x, and when we transform the function with the horizontal reflection, we write it as y is equal to f of negative x. So here, this time it's inside the function. So f of x is equal to square root x, our parent function. Our transform function would be written as f of negative x. Here we'd write it as square root negative x. So the negative is now inside the function or inside this square root here. So when we look at the mapping notation, again, we start with our x, y values. And here, this time our x values are the ones that are multiplied by the negative 1, and our y values will stay the same. Here, when we look at our parent function, so 0, 1, 4, 9 are x values, our y values are 0, 1, 2, and 3, same as previously when we wrote it. And here, transform function with our horizontal reflection, our x values are negative, so it's negative x and y. So here we have 0, -1, -4, and -9, and our y values will stay the same at 0, 1, 2, and 3. So if we graph our original parent function, so 0, 1, and 1, 4 and 2, 9 and 3. So that's our original parent function. That's y is equal to square root x. And here, if we graph our transform function, start at 0, 0 as well, -1 and 1, -4 and 2, and it would continue on to the left. So what we see here is that from the original parent function, the transform function is reflected across the y-axis. So similar to the question before, but now with the y-axis, if we put a mirror there, the two sides should be the same. Okay, so continuing on, here it says graph the transform function from f of x is equal to square root x if it's reflected over both the x-axis and over the y-axis. So here again, f of x is equal to square root x, that's our parent function. So our equation here, it's reflected both over the x-axis and over the y-axis. And so here, if we wrote it in function notation, it would be negative f of negative x. And so here our equation will be y is equal to negative square root negative x. In terms of our mapping notation, both our x and y values are reflected. So therefore, they both will be negative. So here it's negative x and negative y. So here, if we look at our, again, our parent points, again, will be 0, 1, 4, and 9. Y values will be 0, 1, 2, and 3. And for our transformed function now, both the x values and y values will be negative. So here will be 0, -1, -4, and -9. And our y values will be 0, -1, -2, and -3. And so here, if we graph our parent function, 0, 0, 1, and 1, 4 and 2, and 9 and 3. That's our original parent function. Y is equal to square root x. And here, our transform function starts at 0, 0. Then we have -1, -1, -4, -2, and -9, and -3. And so that will be our function. Y is equal to negative square root negative x. That's our transform function there. Next, we're going to look at vertical stretches. So here, if we're comparing the original function, y is equal to f of x, and y is equal to a f of x, now the parent function is stretched vertically by a factor of a. So whatever the a value is, that's what the original function is being transformed by the vertical stretch. So here, a parent function f of x is equal to square root x. Here, 3f of x, we would write that as 3 square root x. And here, if we're going to write what's happening to it, we can write that it's a vertical stretch by a factor of 3. So here we have a vertical stretch by a factor of 3. Here we have 0.5 f of x. And so here we would rewrite it as 0.5 square root x. And here we would also write that there's a vertical stretch by a factor of 0.5 or 1/2. So when we look at our mapping notation, so here, since it's a vertical stretch, it will impact the y values. And so here our x values will stay the same, but our y values will now be multiplied by 3. Same thing here. Our x values will stay the same, but our y values will be multiplied by 0.5. And so now let's fill in our table of values. So our x values stay the same. So 0, 1, 4, and 9. Our y values here are multiplied by 3. So we have 0, 3, 6, and 9 in terms of. So that again is if a, this is an example if a is greater than 1. And so in this example, our a value is 3. Then if our a value is between 0 and 1, so here in this example, it's at 0.5, then we see that our x values will stay the same, but our y values will be multiplied by 0.5 or divided by 2. So here we'll have 0, 0.5, 1, and 1.5. And so when we look at the corresponding graphs to these three functions, so the parent function, the function with vertical stretch by a factor of 3, and then the function with the vertical stretch by a factor of 0.5. When we look at this graph that corresponds with it, we see that the solid line will be our original parent function, so that's y is equal to square root x. And so here, if we think about the vertical stretch, so if it's a vertical stretch by a factor of 3, here we see that that would be the dotted line that's at the top, and then the vertical stretch by a factor of 0.5 will be the dotted line at the bottom. Okay, next, let's look at the horizontal stretches. So if we compare the original function of y is equal to f of x, and y is equals to f of k of x. So now the stretch is inside the function. The parent function is stretched horizontally by a factor of 1 over k. So it's important to recognize that there it's stretched horizontally by a factor of 1 over k, not just the k value itself. So that's different than the vertical stretches, where you just multiply it by a factor of a. So here we have our original parent function, f of x is equal to square root x. Here we have f of 2 of x. So here we'll write it as square root 2 of x. However, when we describe what's happening, here we see that there's a horizontal stretch by a factor of 1 over k. In this situation, the k value is 2. So here we have a horizontal stretch by a factor of 1 over 2. If we look at f of 1 over 4x, again, we write it as square root 1 over 4x. But when we're describing what's happening here, you see that there's a horizontal stretch by a factor, again, of 1 over k. Here it's 1 over 1 over 4, which means that it's a horizontal stretch by a factor of 4. So here, when we look at our mapping notation, this time it's going to affect our x values. So here, we don't write what the k value is, but we write what's actually happening. So here we see that's a horizontal stretch by a factor of 1 over 2. So here, instead of writing 2x, which is what we would see in the equation, we write what's actually happening. So here, it's 1 over 2x and y, and our y values stay the same. And here, same thing. We would write 4x and y. So here, then our x values are multiplied by 1/2 or divided by 2. So we have 0, 0.5, 2, and 4.5. And our y values stay the same. So those would be 0, 1, 2, and 3. And that is if our k value is greater than 1. If our k value is between 0 and 1, here in this example, we have 1 over 4 as our k value. Here we see that it would be multiplied by 4 in terms of the x value. So here we have 0, 4, 16, and 36. And our y values stay the same. So here they're 0, 1, 2, 3. And if we look at the corresponding graphs, our parent function is our solid line. So y is equal to square root x. The dotted line at the top, that'll be our y is equal to square root 2x. And then our dotted line at the bottom will be our y is equal to square root 1 over 4x. So let's look at our last example here. So it says for y is equal to negative square root 1 over 2x, what is the base function? And so the base function here is y is equal to square root x. Again, base function or parent function. Then state the transformations in order and then graph the given function. So here we always start with any reflections. So here we have a vertical reflection across the x-axis. A vertical reflection across the x-axis. And then we indicate any stretches or compressions. And so here we have a horizontal stretch by a factor of 2. So here, our transformation, again here, you see that we have a horizontal stretch by a factor of 2, so that means that 1 over k. So here we see that we have 2x and our y values. We have a vertical reflection across the x-axis, so our y values will be negative y. So 2x and negative y. So here if we look at our table of values, starting with our parent function, 0, 1, 4, and 9. And our y values, 0, 1, 2, and 3. And then our transform function, x values are multiplied by 2, and our y values are negative. And so here we have 0, 1, 4, sorry, 0, 2, 8, and 18, because we're multiplying by 2. And our y values are 0, negative 1, negative 2, negative 3. Here, if we graph our transform function, start at 0, 0, 2 and negative 1, 8 and negative 2, and it'll continue on to the right. So that's our transform function, y is equal to negative square root 1 over 2, or 1/2 x.